All right, now that we know what's happening, okay, I want to take you guys a little back, right? Here, in this situation, remember what we did? We said our volume of hydrochloric acid and our volume of sodium hydroxide will come together, they form 4, right? It's like water and milk. You put them together, they have an added volume. The glass is going to, become more full. So that's what's happening here. Together, they form a volume of 4. But how many moles of HCl do you have now? In this volume of 4, you've got 1 mole. You no longer have your sodium hydroxide. You've just got this 1 mole of hydrochloric acid. That is what you've got over there. Now, that's actually what we just calculated there. We've got 1 mole of hydrochloric acid in excess. So, if this is your HCl, that is in excess. And you've got 1 mole of HCl. But also it's in a volume of 4 cubic decimeters. Remember what we just concluded now. First of all, we just found out what is in the final solution. An acid is in the final solution. But now how do you calculate the pH of that acid in this final solution? pH is equal to negative log H3O plus, or pH is equal to negative log H plus. So we need to know what is the concentration of hydrogen ions in that HCl that is in the final solution. That's why they want the pH of the final solution, right? So we know that HCl, now that it's left alone, it will ionize H plus Cl minus. Okay, meaning that HCl will form 1 H plus and a Cl minus. So it ionizes into ions. We can find the concentration of that hydrochloric acid. This hydrochloric acid, because we know it's 1 mole of hydrochloric acid in a volume of 4, the concentration is number of moles over volume, which is 1 over 4, which is 0.25 moles per cubic decimeters. We found the volume. We found the concentration. Now, how do we find the concentration of your hydrogen ions though? Because that's what we need for the formula. Because we're saying the concentration here is 0.25 moles per cubic decimeters. But what is this? What is the concentration there? Concentration ratio. That is what comes in now. We can say the ratio is 1:1. It's similar to the mole ratio. So 1:1 is telling us that if this concentration of hydrochloric acid is 0.25, in a ratio of 1:1, we can now find the concentration of hydrogen ions. And now you'll see that the concentration of your hydrogen ions is 0.25 moles per cubic decimeters. And that is what you put into your equation there. Now you go on to saying pH is equal to negative log H plus, which is negative log 0.25. And now you can find once again your pH. And guys, because remember, first step was to find out what is in your final solution. Acid or base, it's an acid. Now we just went on to calculating the pH of that thing in the final solution. The pH of the acid, which is 0.60. Stop and ask yourself, does it make sense? We have an acid in our solution. That's the final solution. And the pH is 0.60. Remember the pH scale? Anything with a pH that is less than 7, it's acidic. It makes sense. This is less than 7, right? And we have an acid in our final solution. So if we try to test this pH and it's 0.60, it would make so much sense. It's our acid that's left over.